你现在卡掉就好了。
It's okay.
来 music please.
Okay. Which one do you want?
Super Mario 的 whatever. Hi, hello everybody. I am ready. And today I will show you guys how to do some related rates questions. And these questions are from the AP Calculus exams, right? And these are the multiple choice questions. And as you can see, the first one is from 2003, which is about 15 years ago, right? And in fact, you have to use some implicit differentiation. And hello everybody, whoever is here. I appreciate you guys coming. And did you guys hear the background music? Yeah. How are you guys doing? How are you guys doing? Let me know if you guys are here. I was just trying to get ready earlier. Hi, Rocio. Hello, hello. Yes, Super Mario. Somebody recognizes Super Mario. Should we play? Can we play another piece? Woohoo! Okay, cool. And I think this is the format that I'm going to do, okay? So we'll give you guys some time to try every question, and I'll wait for about like a minute or so, and then I will go over this with you guys. And hopefully you guys have a chance to try question number 1 already, so I will just work this out with you guys. And Wuhan, hello, hello, hello. And Ved, how are you? Change your picture too. Cool. I'm good, and we'll be doing related rates question today. And I think it's about time for us to get ready because you guys have been waiting for a long time already, right? So let's go ahead and get going. So first of all, for the question back in 2003, and this is the AB question, the radius of a circle is increasing at a constant rate at 0.2 meters per second, and we are trying to find out if the rate of increase in area of the circle at the instant when the circumference of the circle is 20 pi meters. Oh, hi, Brian, Mr. McLogan. Hello, hello. Cool. So this is how we are going to do it. It's always easier if you draw a picture, and let me tell you guys that the secret that I found to do the related rates question, right, is to draw 2 pictures. So first of all, I will just draw you guys a picture. Of course, we're talking about a circle, and we have the radius right here. It's r, right? And we know that the radius of the circle is increasing at a constant rate. So originally, we have this circle, but the circle is going to get bigger, right? So the second picture is going to be a bigger circle. And I know my picture is not a perfect circle, but just excuse my picture. And this right here, we care about the instant when the circumference of the circle is 20 pi meters. So I will just write this down. This is at the instant when the circumference of the circle is 20 pi. And now this is how we will do it. We care about the area, right? Because we're trying to find out the rate of increase of the area. So let me just label this right here. This right here tells us that we have to find out what dA dt is, okay? And we know that the radius of the circle is increasing at a rate of 0.2 meters per second. And let me just underline this for you guys. This tells us that we have dr dt that's equal to 0.2, right? So first of all, we will just write an equation with the area and the radius. And as we all know, the area is just equal to pi r squared. And now you have to know that the r is changing and the a is changing as well. Both of the a and r are the functions of time. We will be differentiating this with respect to time, and we will have to do implicit differentiation. On the left-hand side, we get dA dt, and this is equal to, right here, pi is a constant, and we have r squared. Of course, bring the 2 to the front, minus 1, so we get 2 pi r. And because r is a function of time, so we will have to multiply by dr dt, okay? And now, we want to find out what dA dt is. We know dr dt is 0.2. I just have to figure out what r is. And as you guys can see right here, we care about the instant when the circumference is 20 pi. So circumference is 2 pi r. We make this equal to 20 pi. And as you can see, r has to be 10, right? And in fact, you can just plug in 20 pi right here if you would like, but I will just say r is 10, and I'll do the work right here. Anyway, I will just finish this. dA dt equals to 2 pi, and once again, r is 10, and then dr dt is 0.2. And this is pretty much all we have to do. In the end, we can just multiply everything out. 2 times 10 is 20, times this is what? Is it 4 or 0.4? What's 20 times? Somebody is weird. Let me see. I'm going to 4. Thank you. And I'm going to. I don't understand what this person is talking about, but yeah. Yeah. But anyway, 20 times 0.2 is 4, of course, and then we have the 4 and of course the pi. So we have done the first question right here. dA dt is 4 pi meter square per second, and this right here is answer choice C. Okay. Okay, did I do anything right or did I do anything wrong? Let's see, let's see. Unhan, why did you say oops? Oh, I see. You have an extra 2, let's see. It's good. Okay, good. Thanks, Alex. And what else? Let's see. Okay, this is great. And let me know how many of you guys are in high school? How many of you guys are going to take the AP Calculus test in May? Anybody? And I'm going to erase, I'm going to clean this up a little bit. And also let me know how's the video quality today? Oh, cool. So I have some viewers. That's great. You guys are taking the AP Cal test. Cool. So I have Wi-Fi today, so hopefully my video quality is actually better. But it's actually better. But yeah. Okay. So as I said, you guys will have about like a minute or so to try the second question. So I'm going to just shut up, and then you guys can try this on your own. And by the way, if you guys want to work out these questions on your own first, the file is in the description. You guys can go download it and things like that. Okay. Do I have any like music? No? Oh.
It's distracting. You're trying to talk.
Let's go find Oreo.
You want to find Oreo?
Yeah.
Let me bring him. Oreo, people want to see you.
So
You're gonna be live. Please.
how should we
Please, can
show
you-
him though? Because he has to be right here.
Let's just put his. See if he'll like.
Oops. No. This is over. Nope.
That's his hand.
Yeah.
That's his hand. Hi. Hi, everyone.
Aurea is
No.
here.
He does not want to be here.
来，我就 move 一下。Hey, come on, cooperate, please. 老大，大哥。哎，don't.
Ariel.
Okay. He does want to be here.
He wants to like destroy all your
Are you
papers.
serious?
No.
Look at what she did. Okay. Yep, that's Oreo. He is camera shy, so I'm sorry. He just walked away. Okay, anyway, let's continue with number 2. Okay, and this is from 21 years ago, 1997. And this is the BC version, but for the ready rates, you have to do both for the BC and the AB exam. Anyway, right here, in the triangle, we know that theta increases at a rate of 3 radians per minute. At what rate is x increasing? And you guys actually got it right, and I will provide the solution for you guys. First of all, I know this question is not perfectly right here to be constant. Okay, so what's going on right here is that we will maintain the hypotenuse of the triangle to be 5, and we'll just move it to be like this, so that the theta is changing and the x is also changing. Okay, so I will draw you guys the second picture. It's going to look like this. So this right here will be 5. Okay, and then now theta is still right here, and of course x is now here. This is the picture. X is meant to be longer, and theta is supposed to be bigger. Anyway, this is just a second picture, and let's see. I want at what instance? Okay, I want at the instance that x equals to 3. Okay, so I'm going to leave this right here for now, because first of all, I will have to come up with an equation relating the theta, the x, and also the 5. Notice that we have the angle, and then this is the opposite, this is the hypotenuse. So we can come up with the trig equation, right? And we can use which one? Okay, help me out. Which one can we use? We have the opposite and the hypotenuse and the angle theta. Which of the trig functions can we use? Sine. Thank you. Cool. So I will just write this down. We will have sine theta, and this is equal to x over 5, like this. And before you do any differentiation, you can multiply by 5 on both sides, because that way you don't have to deal with any fractions. So 5 times sine theta equals to x, right? And right here, the question is asking rate of changing of x, right? So we are trying to find out what dx dt is. And the hint is, whenever you see rate, that means derivative. And here we are talking about x, so it's the derivative of x with respect to time. Right here, we can just go ahead and differentiate this with respect to time. Remember, x is changing, and also the theta, they are both functions of time. When we differentiate the left-hand side, we get 5, and the derivative of sine theta is cosine theta, but because theta is a function of theta is a function of time, so you multiply by d theta dt. And then on the right-hand side, the derivative of x with respect to time is dx dt. So this is what we have. Okay, any questions so far? Okay, I will assume not. Otherwise, I will just think that, okay, cool. Thank you. Now, dx dt is exactly what we want, right? I just have to figure out what cosine theta is, because in fact, we know the 3 right here represents the d theta dt. This right here is 3, okay? So I will have to find out what cosine theta is. Well, when the moment that we have x is equal to 3, which is once again right here, I know my picture is horrible, okay? This is 3, this is 5. Okay, you guys can blank on flying about math because his picture is actually worse than mine. So anyway, not just kidding. If this is 3, this is 5, how long is this? Okay, 4. Yes, I know the picture is horrible, but just excuse me on that. So right here, remember this is theta. So based on this picture, cosine theta is equal to 4 over 5. Okay, and of course you can just figure out 3, 4, 5 Pythagorean triple. We'll use a squared plus b squared is equal to c squared, right? So we are pretty much done because I can just say this is 5. Cosine theta is 4 over 5, so that's multiplied by 4 over 5. d theta dt is 3, so let's multiply this by 3, and this will give us dx dt. Well, now we can just cancel this, and then 3 times 4, of course, that's 12. So finally, dx dt is equal to 12. So answer E is the answer. Did you figure it out? Edge conditions are interesting. Okay, so that was the second one, and now I have 2 more for you guys for this live stream. Mind your fingers. Okay, so now let's take a look at number 3. Okay, it's also another triangle question, and just like last time, I'm going to give you guys some time, and let's see who can answer this question first correctly. Okay. So I'll start to show you guys a solution if somebody figures out the answer. You want to say hi? Say hi. Oh. Somebody recognized it. Play another one, please. Let's see. I don't know, you can play and people recognize you anyway. Go, please. We are doing calculus today, you guys. I'm still waiting for the answer for question number 3. I'm sure you guys know how to do this. Related rates are okay, they are not that scary. And someone did you see? I am waiting for the answers, you guys. What's the equation that you use? Woohoo! Okay, cool. Now let's take a look at number 3. Right here we are given this figure. Sometimes they will give you the picture, sometimes not. So you will have to know how to draw the picture accordingly. For this one, which is about 25 years ago, in this picture we know that PQ represents a 42-foot ladder, okay? And we have the endpoint against the wall right here, and then the endpoint Q is on the ground level, and the ladder is sliding downward against the wall. And if the distance RQ, which is from here to here, at the instant Q is moving along the ground, 3 over 4 as fast as p moving down the wall. This one, it's not really asking you for the dr, dt, or dA, dt, whatsoever. We are trying to find out the distance, rq, okay? And as you guys can see right here, we have this figure, and let's just use some variables. It's easier this way, right? And we just care about this length and also this length. Vertically, let's label this as y, and let's label the horizontal distance as x. It's easier this way, right? And as I told you guys, we are going to come with another picture, so we will. Let's see. Let me just draw another picture right here. When the 40-foot ladder is sliding down, once again, it's like this, right? It's just like, let me just show you. It's like sliding down, so it's going to be looking like this. Once again, it's like this, right? Going down. So you see y is actually decreasing, but x is actually increasing, right? So that is the idea. So the second picture is going to look something like this. Let me just put like this right here. This is the 40 right here, and this is the y, and this is the x. And we are trying to find out at the instant q is moving along the ground 3 over 4 as fast as p is moving down. So it's kind of hard to label this right here. Let's see how can I label. But anyway, let's come with a picture. Let's come with the equation first. From this equation, from this picture, we know that by the Pythagorean's theorem, we know x squared plus y squared is equal to 40 squared. So let's put that down. X squared plus y squared is equal to 40 squared. This right here, it's a constant. Okay, it's always 40 because it's a letter. And then x and y are changing, so they are function of time. So now I will just differentiate this with respect to time. And this is pretty much how you do related rate, right? Now on the left-hand side, the derivative of x squared with respect to time is 2x dx dt. And then we add it with the derivative of y squared with respect to, okay, I'm going with time is 2y dy dt. And then when you differentiate 40 squared, you just get 0. Okay? So now this is pretty much the equation that we have. And now you have to be careful with this because this right here, it just said that what's the distance of RQ? So in our question here, this is RQ. I'm trying to find out what x is equal to. This is the question, okay? I'm trying to find out x is equal to what? And it's at the instant when q is moving down. So when q is moving along the ground, 3 over 4 as p is moving down. So based on this, it's at the instance that I will just write this down as this is going away, so we will just write down 3 over 4 dx dt equal to, and sorry, this right here says q is moving along the ground, right? So this right here represents dx dt. So I shouldn't have the 3 over 4 right here. We want dx dt to be 3 over 4. And p is moving down the wall. So this right here represents dy dt. So we want dx dt to be 3 over 4 dy dt. So that's the idea. And I'm trying to find out what x is. Okay? So let's see what can we do. Right here, we know dx dt is the same as this, 3 over 4 dy dt. So I can plug in this back to here, right? So let's see, I will just put down 2x times, this is 3 over 4 dy dt, and then we will just add 2y dy dt, and this is equal to 0. Let's see. Do we need a negative moving down? Aha! Because dy dt is decreasing, right? I agree. So we should have a negative here. So we should have a negative here. Okay? Perfect. Thank you, thank you. I missed that earlier. And now this is what we have. And now, what can we do next? Yeah, y was going down. Yeah, so I will have to have a negative right here. Yes. Okay, first of all, notice that dy dt is not 0, right? Because it's moving. So I can just divide everything by dy dt. So let's just do that. And I'll do it legitimately. Divide everything by dy dt. Divide this by dy dt. And divide this by dy dt. So that, cancel, cancel, and it's still 0. And now let's work this out. 2 times negative 3 over 4 is just negative 3 half, right? So this is the same as negative 3 half. And we have the x right here. And we will just say this is plus 2y, and this should be equal to 0. And now, what else can we do? In fact, we have to solve the equation, right? Negative 3 over 4x plus 2y is equal to 0. Negative 40. Okay, you can do it like that. Or I was thinking about I can isolate the y and then put it here. Same thing, right? So I will just do that. Let's move this to the other side. So from this equation, I will isolate the y, and then I will get an expression of x, and I will plug into here, and I can solve for x. So that's a strategy. So move this to the other side. We get 2y equal to positive 3 over 2x, right? And then now I will just multiply 1 on both sides, so that this and that will cancel, and we get y 3 over 4x. And I run out of space, but it's okay, because for paper, I can just pull out the paper right here. Okay, we know y is equal to this. I will just plug it back into the original equation, because this is the connection between x and y, right? So now, this is x squared plus y is that. So I will just put this down, 3 over 4x. And we square that, and this is equal to 40 squared. And I hope this was on the calculus section of the AP test, so we can use a calculator, right? Hopefully that's the case. Anyway, let's try. This is just x squared plus this is 9 over 16 x squared, and this is equal to, you can multiply this out, this is 1600. And this is like 16 over 16, right? Because you get a common denominator. And then you can just add a 16 and 9, that's 25 over 16. X squared is equal to 1600, right? And now let's multiply by 16 over 25 on both sides. Multiply by 16 over 25 on both sides, so that this cancel. We'll have x squared is equal to that. Okay, 25 goes into 25 one time. 25 goes into 1600 how many times? So let's do 1600 divided by 25. Without a calculator, you can do this, right? 1600 divided by 25. And you can just do, let's say, 4, no, 5, no, 6, yes. 6 times this is 150, and then you have 100, and then it's 4, so 64 times. So this is 64 times 16, right? And then you take the square root. So just do the math on your own without a calculator, up to you. This is 8 times 4, so in the end, x is equal to 32. Okay, so we have the answer to this is E. The answer to this is E. Okay, let me just show you guys. Okay, so here is the last one that I will be doing, guys, today. Question number 4. 1988, so that's 30 years ago. 30 years ago. So now it says a person 2 meters tall, okay, he's the tall guy, walks directly from a street light that is 8 meters above the ground. And if the person is walking at a constant rate and the person's shadow is increasing, right? It's getting longer and longer at the rate of 4/9 meters per second. At what rate in meters per second is the person walking? So I'm going to give you guys some time to do this, and we will have some live music going on as well. In the meantime, I'll read the comments from you guys too. Is there any music that you guys want to hear? Let me take a request. Whoever comes first. Final Fantasy. Hey, somebody comments Final Fantasy.
I'm playing it right now.
Oh, never mind. You don't know.
Wii music.
What's Wii music? Zelda. Hello. Thank you for watching. Super Mario.
Zelda.
Oh, I have 20% left. Let's see.
Jazz is so hard.
Okay, my phone only has 20% battery left, and then right now I cannot charge my phone because I'm using the new headphone from like the iPhone, so I can recharge my phone. So I will have to finish the live stream as soon as possible. Anyway, we have to finish this question. So first of all, let me draw the street light, which is, that's it right here, and this is 8 meters, and this is always going to be 8, right? Because this is not going to get any taller or shorter. And we have a person right here. He is a tall guy, so let me just make his legs longer. He's walking away though, okay? So that's an arrow that he's walking this way. And as you know, it's like the light is like this. So this part is his shadow, and then this right here is how, this is the distance from the person to the street light, and he is walking away, okay? So now, this guy is always 2 meters tall. And as I told you guys, we are going to draw another picture, so I will. Let's see. Well, he's just going to walk away. The second picture is kind of the same, but let me try to reproduce the same picture. This is 8, and he's going to be walking right here, right? And let's see. So it's this part, and then this part. This is always 8, and he is always 2. Let's see. You make his shadow and anti-shadow 2. No, This right here is not his anti-shadow. This right here is just distance from him to the street light, okay? This is his shadow. Okay, let's see. So the shadow is increasing at the rate of 4/9 meters per second. So you know this is going to be what depends on what you want to call it. I will call this to be x. It's changing. Likewise, this is also changing. I will call this to be, let's say, y. Okay, I'm not going to be too creative. But here's the deal. You always have to label the quantities that are changing with variables. So that's why I label this as x, this is y, and he's just always 2. He's like this is always 8. I'm going to come with an equation. But once again, this right here, this person's shadow is increasing. This tells us that based on our picture, dx dt is equal to 4/9. And we are trying to find out how fast is the person walking. So we are trying to find out what's dy dt. Okay, so this is what we want. And now, from this right here, and you guys hopefully you have seen a similar example in your class already, we will have to use similar triangle with this picture here. So first of all, if you look at this is a triangle. We can put this down as 2/x, and it's easier to write it down as x/2. We'll just do this over that, okay? So the equation is x/2 if you look at this small triangle. And if you look at the big triangle like this, we will have x plus y over 8, okay? X plus y, because that's the whole base for the triangle, over that. By similar triangle, this has to be the same as x plus y over 8. And of course, if you want to do 2/x, it's equal to 8 over this plus that same thing too. But anyway, this is pretty much the equation. And before you do anything, of course, you can just multiply both sides by 8 if you would like, so that you can cancel this out, and then you get on the left-hand side, this is 4x, and this is equal to x plus y, and then minus x on both sides. Of course, we can end up with nicely just 3x equal to y. So this is actually not bad at all. If you are, okay with geometry and similar triangles, if you have seen these questions in the past, this is actually not bad. Okay, now we will just differentiate both sides with respect to time. On the left-hand side, we get 3, and the derivative of x, because x is changing, so we know this is dx dt, and that will be equal to the derivative of y with respect to time. That's just dy dt. Finally, I just had to plug in this into dx dt, and it will be done, right? So this is 3 times dx dt is 4/9, and this is the quantity that we're trying to find, the dy dt. And of course, you can just do the math on your own. This is 1, this is 3. So in the end, you see that dy dt is equal to 4/3. And with this, we are done, okay? Let's see. Where is the answer? Answer choice D. Okay? So, hopefully, you guys find this video to be helpful, and hopefully you guys like this video. This is Calc 1, and but for the AP Calculus test, you will have to do the related rate questions for both AP version and also the BC question. And next time I'll show you guys some literally BC questions, the series questions. But in the end, I would like to have my wonderful, beautiful girlfriend to play another song for us. So, you don't want to show your face?
No.
Can I show them the piano?
Yeah, I guess.
I will just cover this in it. Yeah. Yeah, 我录哦。
Is it gonna show me?
No. Like,
No.
any request? Would you guys want to hear anything, or just play whatever you want? Just go.
Okay.
1, 2, 3, go.
Hey, someone noticed it's Kingdom Hearts.
Yeah. Angela says you are so good.
Thank you. Yeah,
An infinite.
That's
Oh, cool.
that's it.
One more. Uncle,
One
no?
more?
No, 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 no.
One more?
No, please, yeah, yeah, yeah. Oh.
Yeah,
Yeah.
I think he knows. People are looking at him.
Yeah. Wuhan, are you still here? Oh, we are saying hi to you. Pay him, please. So, okay, okay. Hold my,
Yeah.
him, it's him. 好乖，好乖，好乖，小乖，小乖。Okay, thank you guys so much for watching. I appreciate you guys. And then, if you are new, please subscribe to my channel. Okay, and Oreo will really appreciate that as well. And next time, I will show you guys more AP calculus questions in my live stream. Okay. Bye, Oreo. Bye, everybody.
Say bye, Oreo. Bye bye. See you next time. He's I wanna
Okay.
sleep.
Bye, you guys.